Okay, good evening. Just a couple 11.2 homework examples looking at pyramids here. So this is not a CNP flat top. This is now in that other family of pyramids. Okay, we're going to find surface area. There's a little bit of terminology that I'm just going to briefly explain that you should be able to pick up from the text. And that is um, we have a base. Pyramids have a base, so that right there is the base, and we'll use a big B to for the volume, or I'm sorry, the area of that base. We also have edges. This right here is an edge. Okay, that's an edge right there. We also have, so I'll note that in blue, that's an edge. This is an edge. Back here is an edge, and this one right here is an edge. Again, we have lateral area. Lateral area. This triangle here with this triangle here is lateral area, and then around the back side, on each side, we've got lateral area. So let me clear that off since it's getting a little bit messy. So we've got lateral area, and that's these triangles. Back on that side, and back on that side. We have edges we talked about. Okay, slant height. This right here is slant height. It goes perpendicular from the vertex perpendicular to the base. So this right here is what we call a slant height. That is different than the height of the pyramid, which it drops down inside here. Can you picture the difference there? This actually makes for a triangle. This right here is a triangle. This purple line is the height of the pyramid. So we have slant heights, we have heights, we have edges, we have lateral faces. Lateral area comes from lateral faces. And we have bases. All right, lot of terminology. Okay, let's move ahead. So here's a problem. We're going to try to find surface area. So objective is surface area of this pyramid. This is what we would call a square pyramid, and that square represents the base. Square pyramid. So suppose this square pyramid has lengths of 10, and it has a slant height of 12. We should be able to find, that's all the necessary information to find the surface area. So let's take it a bit at a time. What does the net look like? This might help you. If I unfolded this, I would have that square base with 4 triangles. Let's find the area of each of these triangles. Let's find the area of that triangle first. Well, the area of a triangle is 1/2 base times height, and the base of this triangle is 10, multiplied by the height is 12, and that equals 5 times 12, or 60 units squared. So if this one's 60 units squared, 60 units squared, this one is 60, 60, 60. We have 60 units squared times 4 of them to get 240 square units. All of that is my lateral area. So lateral area is 240 units squared. And now I'm left to find my base. So find the area of the base. Area of the base is equal to 10 times 10. Is 100 units squared. And now I add those up to find my total. 340 units squared. Now, that one went pretty quick, pretty easy. Now, the trick of pyramids is, given the information, whatever information you're given, can you find what else is necessary in order to find the areas? So, for example, I could look at, I'm going to clear this one out, and suppose, again, this was a 10 by 10, but I didn't know the slant height, but I knew this edge was 13. This edge was 13. Now, the edge isn't very helpful insofar, it's only helpful insofar as it helps us find something else that is necessary. So to find this triangle, I need to find this height right here, and that helps me do that because this is a right triangle. And this right triangle I know because my altitude divides that in congruent parts. So this is 5 and 5. This is a 5, 12, 13. I'm back to my own, the pyramid that I just got done solving. So you have to be a bit savvy with the information that's given. Let's look at another example here. I'm going to draw now the height of the pyramid. Okay, so that's being dropped down just like on a cord or on a string. I just dropped it down. That's perpendicular to the base, and this is 8 units. Okay, suppose that this square is a 12 by 12 by 12, 12 by 12 square. Again, what is the surface area? All right, so given this information, can you go and find everything else? Well, what is it that I really need to find? I really need to find the slant height again. That slant height is so important to find the surface area. Well, what do you know? This looks like a right triangle to me. Do I know the parts of this right triangle? I sure do. This is an 8. This distance here has got to be 6. It's got to be half this distance, right? 6 and 6 make 12. So this is a 6, 8, must be 10, and now I'm on my merry way. Find my area of each triangle. It's going to be 1/2 base times height, which is which is 60 units squared. And I'm not going to go through all of that again, but now that I know each triangle, multiply that by 4 and add it to the area of my base, which is a 12 by 12. So again, just to kind of give you a hand with some of these problems, the trick is going to be, given the dimensions that they give you, can you find other necessary dimensions? Things that you should be thinking about: right triangles, Pythagorean theorem, Pythagorean triples. Those are the types of tool sets that you need in order to be successful in finding the surface area of these. Now, I just did an example of a square pyramid. We can have triangular pyramids and other sorts of pyramids, hexagonal pyramids. If it was a hexagonal pyramid, I'm not going to try to even draw it. I will draw its net. Its net is going to look like this, right? Okay. And again, all of this would make for lateral surface area. And then you still have your area of the base that you need to add to it. All right. So with that, I'm going to conclude for the evening. Hopefully that's enough to kind of get you out of a jam or help you see the forest for the trees. So with that, we'll see you tomorrow. Good night.